So the next topic we wanted to talk about is analyzing the watershed and collecting data. Okay. Now, back to our analogy here of CSI. We've looked at the investigator, the crime, the victim. Now we're going to look at the process. What's the process for investigating this crime? First, we have to analyze the crime scene. What's the setting? Well, in terms of benthic stressor analysis, that setting is the watershed. Now, ideally, we would like to do this well in advance before establishing the TMDL monitoring plan, okay? Because there's some elements that as we analyze the watershed that might bring up some questions or issues with what else we might want to monitor, or maybe where we may want to monitor. So the first thing that we want to look at in terms of the watershed is we want to look at the spatial pattern. Okay, I've got a pretend watershed over on the right here. It's outlined in green, and I've got 3 different benthic sampling locations within this watershed. They're labeled 1, 2, and 3, and then the colors indicate what their VSCI scores are. So the one in blue, they're number 1. That indicates that it's an unimpaired benthic condition. 2 here indicates that there's an impairment, and there's an impairment here on 3. So we're doing a TMDL for this main stem right here, where 3 is. This is their listing station probably. This may be an alternative listing station. Maybe we have segmented it up to here perhaps, and then this is maybe a different segment. It could differ. But one of the things we want to do very early on is look at the spatial patterns of this network. Okay, and so what clues does this spatial pattern give us? Let's take a look. Well, one of the things to consider is land use. Okay, what are the land uses within the watershed? And sometimes, you know, maybe we rely on the contractor to do this once the TMDL started. If we can do this early on, right, this will help us. Because as you saw that spatial pattern before, maybe it didn't make a whole lot of sense as to what could be some causes of this impairment. Now maybe it makes a little more sense, right? If we see some land uses here and we see, oh, there's a lot of ag in this part of the watershed, and this particular branch that's draining that area is impaired, and then we see an impairment farther downstream. Well, are there some agricultural issues within this watershed that are leading to impairment at both sites 2 and 3? Site 1, as we can see, well, there's not as much influence from that agricultural area, so maybe that could be an indicator of what's causing this particular impairment at 2 and 3. Now, one of the things we really would like to do is not just have overall watershed land use information, but we would like to have land use information specific that drains to each of those benthic stations. So in this case, this figure down in the bottom left shows station 1, how much forest, how much ag, how much urban drains to this location. Well, as we can see here, it's mostly forested, right? Well, that kind of explains why station 1 is likely unimpaired. If we look at station 2, very high concentration of agriculture, and you know, urban land uses are increasing there. This probably provides some indicators or some lines of evidence as to what the stressors may be. And then as we go down to station 3, what do we see? Well, we see kind of a combination of what occurred at station 1 and station 2, right? A little less forest, a little more ag than station 1, a little more urban than station 1, 2, but not quite as developed as station 2. So that information, the specific land use information for each station, is much more helpful to us than just the entire watershed. If you look at the entire watershed, you might say, well, there's only 26% ag in this watershed. That's not a lot. There's only 3% urban. That's not a lot. Once we look at the spatial pattern and the individual watershed land uses flowing to each station, the pattern becomes a little more clear. We also want to look at point sources. Again, very early in the process, what are the point sources within this watershed? All right, just for this example, let's say we have one here. All right, well, what does the spatial location of this point source tell us about particular impairments? Well, we know for starters that the impairment in this watershed cannot be solely due to this point source. It may have an influence here at station 3. Okay, it might have an influence here at station 3, but it's obviously not what's causing an impairment here at station 2. So obviously there's some other sources of impairment besides this point source in this particular watershed. Other things to look at, the soils and topography, historical activities or disturbances within the watershed. Technical advisory committees can be really great for helping us find out, what's some history of this area? What are some things that maybe occurred in the past that are still influencing the watershed? Again, you might not be able to do all of that early in advance because you haven't developed the TAC meeting yet and TAC groups yet, but you probably know who are going to be members of that TAC. So reach out very early in the process and say, hey, coming up next year, we're thinking about a TMDL. Maybe you're talking to the Soil and Water Conservation District employee. We're thinking about a TMDL coming up in the next 2 years in this watershed. What can you tell me about it? And that might help in terms of planning for monitoring for the TMDL. All right, next thing we want to do, after we've analyzed the watershed, we want to develop our suspect list. Okay, who are the potential suspects? In this case, the pollutants or candidate stressors, we call them, that could possibly be impacting this particular watershed. Again, I would encourage you to do this before establishing the TMDL monitoring plan, right? Because if you come up with some pollutant that might be a stressor after you've already developed your monitoring plan, well, you haven't collected any monitoring data to either support or refute that particular candidate stressor. So what might those candidate stressors be? Here's a potential list for you here of different pollutants. You might want to look at what you've learned from the watershed. Okay, start with a standard list, maybe add things, some input from the technical advisory committee. If you already have some available data that might point in a direction or two, make sure those candidate stressors are included as well. And this is where I was talking before in answering one of the questions about additional contributing factors. We may want to add, to this list of potential stressors. These are things that we can deal with in a TMDL, right? Things like sediment we can deal with in TMDL. We can do a nitrogen TMDL or a phosphorus TMDL. But here's some other additional contributing factors that we should consider, and we should consider them in the stressor analysis. And they're things like, the habitat. Obviously, the habitat may be closely tied with some of these, but there may be some issues of habitat that can't be captured by some of these pollutants. Do they have some legacy issues? I mentioned dams, historic land use practices, hydrologic alteration. Those are things that we can't really develop TMDLs directly for, but we know that they impact benthic communities. All right, then the next thing we have to do, we've looked at the watershed, we have developed a list of potential candidate stressors. The next thing we have to collect some evidence, okay? And how are we going to decide what to collect, where to collect, okay? Collecting data. Again, I would implore you to plan early in this process, okay? If you do the watershed and the candidate list first before you establish your monitoring plan, it will help you in the long run. I know we've all been in situations where we get started on the TMDL and we're like, oh, I wish we had more information, maybe from this part of the watershed or more information on this particular parameter. Again, we can reduce those problems if we plan early. Okay. Secondly, spatial distribution. Really important. Do we have enough stations, and do we have those stations in the right places? Okay. Again, I use this same example over here of this watershed, and in this case, here's our ambient station. Now, We've got benthic stations both above it and below it. What we would love to have is a co-located ambient and benthic station. That's not always possible. But the problem with this particular ambient station is any sources of stress that are coming from this point source, they're not going to be captured in all of our parameter data. Okay, so we would really like to have an ambient station down here, right? Or maybe a benthic station co-located with its ambient station here so that we can know and compare, okay, well, what's the level of stress here where we're collecting all of our water quality data? How does it compare to the level of stress here or here? Because we're going to be using that water quality data to try to say something about the sources of stress. And there's a little bit of problem here because that water quality data doesn't absolutely align with where we're trying to predict the stress. Okay, we would love to have stations that bracket a source. Okay, that's the best line of evidence supporting or refuting a particular stressor. Again, it's not always possible, but we should consider it early on in the TMDL monitoring. Do we have a local reference within this watershed? So this is a TMDL watershed, right? And we have this station number 1 here. It's unimpaired. That makes a very good natural built-in reference site. That's very useful for us. If we don't have one, maybe we do a little bit of looking and maybe try to establish one, as well as a regional reference. Okay, is there, maybe we can't find one in this watershed, but is there a close by reference? Now again, when you think about references, there's a couple different types of references. What I'm talking about here is a benthic reference that has unimpaired conditions. Not necessarily one that we're going to use to compare for the TMDL. Okay, it's not necessarily a TMDL reference watershed, but it is a benthic reference watershed. And so what's the purpose of that? Well, we can look at all of the water quality parameters that we see in this TMDL watershed, and we can compare them with the water quality parameters of this unimpaired site. And if we see differences, aha, that's a good line of evidence to support maybe that's a parameter that's impacting this particular benthic community. All right, and some station considerations. Co-location, again, really important. The more we can have co-located sites, the better off we are. And then consider adding stations. They don't have to be long-term stations. You can actually gain a lot of information just from a one-time synchronized visit where you go and in this case, maybe you do benthic monitoring at stations 1, 2, and 3, but maybe you add another station here at the ambient location. That doesn't mean you have to establish it as a new benthic station and visit it every 2 years, but at least for one time, it lets us compare on this given date what were the different levels of stress at these different locations within the watershed, and how do they relate to the data that we're collecting at this ambient station. So again, it can just maybe be a one-time synchronized visit, but it gives you a lot of information. So in this particular watershed, where might we want to add stations? Here's a few potential recommendations, right? If we added a benthic station here at 4, it would give us a couple benefits. It would allow us to bracket this point source so that we know conditions above and below it. That may give us some information as to how much this point source is influencing this downstream station. Also, a station here at co-located with the ambient station will also allow us to better compare our water quality data. Okay, maybe a station up here called 5 might allow us to investigate our theory of land use-based stressor. Okay, maybe this also has high agricultural influence, and if we see low VSCI scores here, it might add support to our theory about what's going on in this particular watershed. Maybe, again, this one might, number 1 might be used as a within watershed reference. If we didn't have that, maybe we want to try to establish another one Okay, somewhere in the watershed where we know that the land use suggests that it may be unimpaired. All right, and what parameters are we going to consider? We've looked at stations and where are we going to locate those stations? What parameters are we going to collect? Okay, well, if we've developed our list of candidate stressors, we need to have some water quality data for each of those. And then some other types, relative bed stability analysis. Okay, if we suspect there's a sediment stressor, that's one of our candidate stressors, we might want to do relative bed stability analysis within this watershed. Okay, again with this, it may be really helpful not just to do relative bed stability analysis at one point in the watershed at the most downstream station, but maybe if we have an impaired and an unimpaired station within the watershed and we did it in both, that could be some really good information to compare those two sites to say, okay, what are the sediment conditions here versus there? And may that be a line of evidence supporting sediment as a stressor. Diurnal dissolved oxygen monitoring is another thing that if DO is one of our candidate stressors, we probably need to do. Our typical ambient water quality collections happen during the daytime. And unfortunately for dissolved oxygen, if we have nutrient conditions, daytime dissolved oxygens are going to be great. Matter of fact, the more impaired a stream is with nutrients, the higher the dissolved oxygen is going to be during the day. Because we see these large daily swings where during the daytime photosynthesis occurs and organisms are algae are putting dissolved oxygen into the water during the day, but then at nighttime they're consuming it, as well as all the other respirators. They're taking dissolved oxygen out of the water during nighttime. So we really need that diurnal, what's happening in the middle of the night, to really answer the question about dissolved oxygen or not. The best time for that is during the dry, hot summer conditions, because those are going to be our most critical. But you can also gain some information if, depending on the timing of the TMDL study and other things, you can still gain some information in the spring and fall. It doesn't necessarily have to be those critical conditions, because one of the things that you're looking for is you're looking for swings in dissolved oxygen. And those you may actually see as much or more in the springtime and in the fall. And sunlight is actually as important as temperature for dissolved oxygen swings. And sometimes in the spring, before tree canopies come out and before all the leaves are on the trees, you may actually see some real nutrient issues with algae, because a lot of times that algae will bloom before leaves get on the trees. And so you might be able to pick up those large daily dissolved oxygen swings at that time. And you can also use percent saturation as a measure. During the spring, when temperatures are maybe a little cooler, you may not see, in terms of in a milligram per liter range, dissolved oxygen dip that low, but you may see it in terms of a percent saturation. It might dip low. Okay. And then how long should we do these diurnal studies? Probably a week or two is best. If you go much more than a week, you're probably losing your calibration of your instruments. Depends on storm events too. You'd really like to have a time period where you don't have any storm events, because those storm events really kind of interrupt the natural daily diurnal cycle of dissolved oxygen. So if you can, pick a 1 week time period where it's going to be very sunny and you're not likely to have storms, that would be best conditions. And what are the sources? What are data sources? Well, obviously we've got DEQ data, but is there data from stakeholders as well? And I would encourage you at your first technical advisory committee meeting, ask stakeholders, do you guys have any data that would help with this particular project? Not only does it give you more data, but it also builds buy-in. If you're using stakeholders' data, they're probably much more involved with the process, because they feel they have ownership and have stake in the process. What do we do about citizen monitoring data? Well, I want to distinguish here between the assessment process, where we use citizen monitoring data if it's tier 3 level data, and we don't use maybe tier 1 level data. In the benthic stressor analysis, we don't necessarily have to have those same rules. We can use citizen data of all calibers because, and later we'll talk about the CADIS process, we're able in the stressor analysis to consider the results of that based on the quality of that data. Okay, so data with greater quality might receive greater emphasis in terms of scoring lines of evidence than data of higher quality. Okay, and so typically what I would suggest with citizen data, or if other stakeholders have data that they present to you, my suggestion is not to use that raw data. Usually we have plenty of DEQ raw data to use in the analysis, but I usually incorporate it in another section called additional data. And rather than mixing in all the raw data together and coming to conclusions, we use DEQ's raw data and we come to some preliminary conclusions. And then we look at other data, could be citizen data, could be, maybe there's some municipalities that have done studies or projects that have reports on them. Maybe there's some local universities or colleges that have done some particular studies. That data you can include in another category called other data, and rather than looking at the raw data there, look at the conclusions from those studies. Okay, what did those studies conclude, and how does that compare with what you found from DEQ's raw data? For example, there's a quote down at the bottom here. Maybe this could be something similar to what you could say. The county's water supply study supports sediment as a primary stressor. The study identified 6 miles of extremely eroded banks within the watershed and estimated that sediment was filling the reservoir at a rate of 3,000 tons per year. All right, so that maybe was a study done to see how long their reservoir was going to last, but it's within the same watershed as this TMDL study. I'm not going to go back and look at all of the raw data from their study, but I can look at the conclusions and say, you know what? Well, their conclusions were 3,000 tons of sediment per year are coming into the reservoir, which means there are very active sources of sediment within this watershed. And you know what? That supports the conclusions that we've already found from DEQ's data, right? From habitat data, from relative bed stability data, from the benthic data. All those things tend to point towards sediment. Well, here's an outside source of data, right? In this case, the county water supply plan that also kind of confirms the same thing. So that's the way I would use outside data from other organizations, from other agencies, and even from citizen monitoring networks. All right, timing considerations. I mentioned it before, but do these things early. Okay, the earlier, the better. Make monitoring plans maybe 3 to 6 years out. Do those preliminary watershed analysis before making those plans. Pull some archive data, look at it. As you're pulling data, a couple things to be aware of and to keep in mind. Watch out for changing methods over time and changing stations over time. If that is a particular issue, you may want to truncate some of the data that you use in the study based on a change in a method or a change in a station. But typically, the longer time period of data you have, the better. For benthic stressor analysis that I'm doing right now, for most of them, we've kind of started the collection period in year 2000. So we're looking at about 20 years of historic water quality parameter data for the current ongoing benthic stressor analyses. All right, we're almost perfectly on time here. I'll stop again to check in with folks. Again, if you have questions, put those in the questions box. And here, I'll let you read on your own a few things to maybe think about. They may spark some ideas. They may also spark some future discussion topics. So I'll pause here And I'll ask Rob and others what they're seeing in the questions box.
A couple of questions trickling in. The first one is, you mentioned synchronized benthic and chemical monitoring visits. The pollutant loading levels are important, so flow monitoring seems pretty important to that synchronous monitoring. When do you recommend that we need to coordinate with our flow monitoring staff to get some or all of that info for benthic TMDL development?
Actually, I don't think that the flow monitoring is as important for the benthic stressor analysis as it is perhaps for the TMDL development. I think the TMDL model relies more on flows and developing loads than the benthic stressor analysis does, because organisms respond to concentrations. Organisms don't respond to loads. They respond to concentrations. And as we can get a handle on what those varying fluctuations in concentrations are over time, we're very able to tell what stressors are, even without having any flow data. Now, flow data is always helpful. If we have it available to use, that's great. I think it's more useful, though, in the TMDL modeling process, though, than the actual benthic stressor analysis portion.
Sure, that makes sense. As a follow-up, also with respect to synchronous monitoring for benthics, if some of the stressors likely caused a lack of benthics a while ago, then current levels of a pollutant stressor may not be as useful. I'm not arguing against synchronous studies. They're always better than not having them. More data is almost always helpful. But highlighting that the synchronous or current stressor or pollutant levels may not be as relevant to current benthic scores. I guess that was a comment.
Yeah, and when I talk about synchronous, I'm actually talking more about synchronizing some additional benthic stations within the watershed with the long-term listing benthic stations. Of course, having simultaneous collection of the benthic and water quality is great, but what's most helpful is having, on a given day, I've gone to 4 different benthic stations within this watershed, and I know spatially how the stressors compare within the watershed. That's the most useful approach to synchronous monitoring. It's really in the synchronizing the benthics at multiple places in the watershed. Synchronizing it with the water quality parameters is less important, actually, because what's impacting the benthics on that day that you sample is not just the water quality on the day that you sample. Obviously, it's the water quality for the last 6 months. So yeah, I wouldn't really go to that grade of lengths to try to synchronize the dates of your ambient sampling and your benthic sampling. I don't think that's that important. But I would try to think about establishing some new benthic stations spatially within the watershed and sampling those on the same date.
All right. Next question is, how often does a TMDL watershed have more than one benthic sampling site?
Well, oftentimes, we're accumulating. We're doing a TMDL study for larger watersheds where we might have 4, 5, 6 TMDL streams within that larger watershed. And so within that context of nested TMDLs, we actually do have a lot of projects, right? Not a lot of individual TMDLs, but a lot of TMDL projects that have multiple stations within a larger watershed. And we can use all of that information against one another to help in the stressor identification process. It depends on the size of the watershed.
Right. Okay. Is there data you would recommend we collect to evaluate things like hydrologic alteration because of dam or urban area?
Oh, that's a good, tricky question. That's tough. That's tough to tease out. Some of the measures within the relative bed stability analysis kind of get at those questions. But there's probably some other better approaches and better techniques. I'd have to do a little bit of research on that to say for sure, but the size and shape of the channel can often tell you a lot about how the stream is actively responding to changes in its hydrology.
That sounds like a pretty good discussion to have outside of this framework as well. So we'll add that to our list of potential future discussions.